I I have some appreciation for your plight. I'm an old guy. It wasn't that long ago that I was in a classroom setting, and I love to learn, so I still go to classes and various things. You guys know that I've been attending Hebrew classes, and I like to learn. When I'm in a class and I know I have to take a test on subject material, I prefer to do that whenever it's relevant to the test time. So I know that I'm going to lose you now for the next 20 minutes or so. I will try to be as animated as possible to keep you interested. But I think it would be fair today. I'll be able to catch up, and if I can't catch up, I can always put a lecture online for you guys. But I think it would be fair to me today, at least, to let me review with you what you should really already know about digestion. That way, I can leave the parts of digestion, the functional pieces of digestion, I can leave that for the lectures to come after your exam on Wednesday next week. Okay, so what are some things that your teacher would have expected you to bring with you to this class from anatomy? Let's do that today. All right, so this is a section of stomach, and if you're going to talk about the physiology of the digestive system, you have to have in the back of your mind the structure. This is one of those places where the anatomy is really important in understanding the function. So, I remind you that the digestive system, from the top to the bottom, has 4 typical layers: an inner mucosa, a connective tissue submucosa, a muscularis layer that normally has 2, not 3 as this shows, and a serosa. Remember that the serosa of the GI tract is in most places called visceral peritoneum. There are some structures that are retroperitoneal that lie outside this, and so they'll have a different arrangement of serosa, visceral parietal layers. But most of the places in your GI, your stomach and your intestines and all, have an outside connective tissue sheet that is actually a fused piece of the bag that the intestine sits in, the peritoneal bag that all your digestive system organs operate in. Now, the mucosa itself is set up into some layers. These will be important for the physiology, especially in the stomach and the small intestine. So that's why this is a picture of the stomach. This layer will be of particular importance. What we find here is that it has a surface epithelium that is made up of simple columnar cells. Now that you should have known from the fall. The lining of the GI tract is simple columnar, 1 layer of column-shaped cells. Now, I have a blow-up of some of these column-shaped cells down here, and this is where it's going to have some real impact for you in the digestive system content. Because as you can see here, the various cells that are lining the mucosa, columnar epithelial cells, have different names. You can see here that this one is called a parietal cell, and this one is called a chief cell, and this one is called an enteroendocrine cell. And the reason they have names like this is because they are producing products. These are hormone / enzyme producing glands. These columnar epithelial cells are in fact endocrine glands. They are making hormones, and we're going to need to identify the major ones that are produced by these cells. So when I point out the mucosa and the surface epithelium, look for it. The stomach layers make products. The small intestine epithelial cells make products, and we'll want to identify those products and talk about what they do. That's the physiology part. Now, the next layer of the GI tract here is called the lamina propria. Once again, this is a very important piece for physiology. You should have, I know it's been a while, so you should have recognized that word. The lamina propria is the connective tissue layer of the mucosa. The important part for physiology is going to be that the lamina propria in the small intestine is where absorption happens. So you don't see it on this picture, but it's coming. You're going to absorb things in the intestine. If you're going to get stuff into circulation, you have to absorb them across columnar epithelial cells and into the vessels of the lamina propria. So in the small intestine, we're going to find vessels there. They will be regular capillaries and lymphatic capillaries in the intestinal villi. In the lamina propria, this will be the key place for us to talk about absorption in the blood vessels of the lamina propria. The next layer of the mucosa we call the muscularis mucosa. Please don't confuse this with the muscularis externa. They are both smooth muscle, but the muscularis mucosa is primarily there for folding. Now, if you're going to make the digestive system work, this is an important anatomical observation. If I have a sheet of paper that was as big as this table, a flat sheet of paper, I could measure with a tape measure across the length and the width of this table, and I could tell you the square footage, the surface area on this table. Now, I could take a piece of paper from the end of that table all the way over to that wall, and I could start folding that paper. And I could take a piece of paper that goes all the way across here, and I could fold it into a space that would cover probably less than half that table. Just folding it on itself, make a little accordion-looking thing. So I would have all of that surface area, but I would have it in that little space. That is arguably the most important anatomical observation that can be made in the GI tract. Its surface area is enormous because of all the folding. And this smooth muscle layer produces the macro-folding patterns that we see in the walls of the GI tract. The muscularis mucosa is an important piece for folding and creating surface area. The next layer is the submucosa. This is the connective tissue. And there are some important things there. I'll let Dr. Boyce teach you how to tell the submucosa of the duodenum versus the ileum, etc. Peyer's patches are here. There are various glands that will help you identify them in a histological section. Brunner's glands show up really early in the duodenum. So there are a few things interesting to say about it. We're not going to belabor the point here. However, just outside the submucosa, working my way from the lumen out, just outside there, is a nerve net called the submucosal plexus. The submucosal plexus. Now, I didn't learn it by that name. The name that I learned, and so I want you to know it, because I know that when you have anatomy at the next level, your anatomists are going to be older than me, and they're going to use these names. The submucosal plexus is called Meissner's plexus, and I'm about to teach you a second one, which is called the plexus of Auerbach, or Auerbach's plexus, or the myenteric plexus. Now, the reason I point these two out to you here is because these two are the nervous system of the gut. The submucosal plexus and the plexus of Auerbach. These are the nerve nets of the gut. Now, why are you making such a big deal about that? What is the big issue about these nerve plexus? Now, when I say plexus here, you think about nerves that run together, crisscross each other. Another way to think about it, I think is a fair way to think about it, is to use the word net. Because this is really, when you make a varicosity, can I use that word? Where the ends of the axons are just lying along the cells, they don't plug into end plates like skeletal muscle. Y'all remember that? So these are all varicosity connections in the nervous system. And it's like you've got a sheet of muscle there, or a sheet of connective tissue there, and between those two sheets, you laid a net down. Now that net is actually nervous tissue. These are neurons in that net. And they're stimulated, these neurons in that net are stimulated by acetylcholine and norepinephrine and other chemical messengers. But I said those two on purpose. Why do I say acetylcholine and norepinephrine when I talk about the nerve nets? Autonomic. Norepinephrine makes you think fight or flight, name of system, Sympathetic. Acetylcholine makes you think rest and digest, and parasympathetic. Okay, so these systems influence these nerve nets. One between the submucosa and the muscularis, and one between the two major muscles, circular and longitudinal muscles that are in the system. They're nerve nets. Now, I wrote this on the board in the fall. I don't honestly remember doing that, but I always do. I always write it on the board in the anatomy class because I know how important this is. And the reason I wrote the following term on the board, I'm going to illustrate for you here with a slide from Maryam's IP module set on the digestive system. In this module set, she says, the parasympathetic and the sympathetic divisions of the autonomic nervous system regulate the digestive tract. And when a physiology student reads that, they go, please tell me something I didn't know already. You guys can put the neurotransmitters on these and the receptor types already. Now, the autonomic fibers contact the neurons in the GI tract. Notice what she calls it. Does that look familiar? I'm hoping that looks familiar. The enteric nervous system. This is considered by many to be the third division of the autonomic nervous system. You see why I mentioned that I know that I wrote this on the board as an aside? Everybody learns sympathetics and parasympathetics. In the course of a physiology class, you should also become keenly aware of places in your body where there are autonomous, self-existing, self-stimulating, self-regulating nervous systems. You learned about one in the heart. The truth is, your heart will go on its own, and you know why. You can explain that in terms of the channels, the calcium and sodium channels in the SA and AV nodes. They'll go on their own, but they don't. They're influenced by sympathetic and parasympathetic. We have a special name for it. We call it the specialized conduction system of the heart. It'll do its own thing. So the reason I bring that up is because this is the same phenomenon. The gut will do its own thing as well. In fact, when you get a bolus of food in your system and it stretches the walls of the intestine, it will actually stimulate peristaltic waves. You don't have to have parasympathetic influence to do this. Now, do you normally have parasympathetic influence to do this? Yes. But it's important to point this out to students, the importance of this enteric nervous system. So, what are the components of the enteric nervous system? These two plexuses. So let's look at them one more time. Here they are. First, there's a plexus between the submucosa and the first layer of smooth muscle. That's why I put this graphic on here. So you can see from the submucosa, there will be a plexus, and then you have the muscularis circular layer. This is the way this works. This is the next layer. So most of the time, through most of the GI tract, the next layer is circular. It's smooth muscle cells that go around the lumen. So these are all tight junction connected cells. We learned all this. They're all smooth muscle. They circle the lumen. When they constrict, the lumen gets smaller. So these two plexuses are going to influence the contraction of these muscles. Now in the stomach, you will remember in the stomach that there's an extra layer of smooth muscle. The oblique is the most internal, and this is the picture I used in the fall right here. You can see the oblique smooth muscle layer on the inside. The next one is circular, and then the next one is longitudinal. What's missing on this picture is the plexus of Auerbach. It's not pictured for you here, but it's between the circular and longitudinal layers. So I think most physiologists would say that this one, the plexus, that the nerve net that is laid out between the circular and longitudinal muscle, is more important than this one in the muscle contraction. And you can see why. It's between the two muscle layers, between circular and longitudinal. All right. So submucosa, submucosal plexus, then smooth muscle. Most of the time it's circular and longitudinal with the myenteric plexus between them. The stomach has an extra one, an oblique layer. It speaks to the function of the stomach. The stomach is like a washing machine. The stomach is not really designed to do peristalsis or segmentation like the intestine is. The stomach is designed to move in multiple directions, to mix. The stomach is a mixer. So the product that you come out with is something called chyme. We'll talk about the details of that after your next exam. All right. So that's my anatomy review with you. I am ready at this point to begin talking about the details of physiology. So I'll tell you how that's going to go, and then I'm going to turn you loose. Here's how this is going to go for the intestine. This is what we're going to do for digestion. I want to focus in on the story of eating. So you'll see on each of these slides as we go through it, I've made little notes on them, timing notes. It's a few seconds in your mouth. How long is it in the stomach? How long is it in the pylorus? What does the pylorus do in real time to get things to move out of your stomach into your intestine? What does the intestine do in response to that? What are the things that are released into the intestine whenever the pylorus squeezes its 3 millimeter pieces every 20 seconds because of these BER cells of Cajal found in longitudinal muscle? They are fantastic. The physiology of that is fantastic. And I want you to think about digestion as the progress is happening in real time. How much time is it in here? How much time is it in here? What happens to it? What does it look like when it comes out of there? What are the cells that are making the products that are mixing it up? And so we're just going to move down. I'll mention the esophagus briefly and the cardiac sphincter, and then we're just going to move down through the stomach. So we're going to start. We're going to talk about how long it's there, what products are being made. We're going to talk about the different phases. We're going to talk about the different phases of these things that happen. I see it and I think about it, and the stomach's got to do something, and then the intestine takes over. And so we've got various phases to go through as we work through the physiology. And all along the way, the hormones and the nervous system and the cool functional pieces I'll point out to you as we go through it. Doing it that way means that there's a lot of real nitty-gritty details that I leave out. But I think that after we've done it this way, you'll get to the end of that and you'll have some things you'll remember. I like to think about the students sitting in the classroom because I've been there. Why don't you tell them, Wade, what you wanted to know when you were a student? Instead of just listing random facts, let's tell the story of digestion. And so that's the way I do it. We're going to talk about the nervous system and the hormones and the phases and the timing. When you get done, somebody asks you, I just ate something, what's going to happen to it? You'll be able to tell them a story about what happened to what they just ate. All right, about 20 minutes early, letting you go. I have tried to stimulate your initial interest in digestion. The physiology really begins at the time. Now, you've never let me down on this before. I'm counting on you guys studying over the weekend. So you have to come and talk to me about heart and blood and immunity and respiratory. You're going to talk to me about that on Monday. Let's have a learning session together on Monday for the test on Wednesday.